Today we're going to be talking about tests for parallelograms. And back when we did parallel lines, we talked about properties of parallel lines, and then at the end of the chapter we talked about how to prove lines parallel. This is kind of what we're doing today. Yesterday we talked about the properties of parallelograms. Now we're going to use those properties to prove quadrilaterals are parallelograms. Okay, so just as a refresher of our properties of parallelograms, okay? So one of them was opposite sides are congruent. Opposite, I can't spell opposite, above, angles are congruent. Diagonals bisect each other. And then two, let me write that so it looks like a two. Two pairs of parallel sides. Now the opposite of these are going to be or the converse I should say, are going to be the ways to prove a figure is a parallelogram. And there's a few other additional properties that we use in order to prove a parallelogram. One of them, and again, like I've been saying in previous videos, if you need to pause this to write down all these, please do that. Both pairs of opposite sides of the quadrilateral are parallel. Then you have a parallelogram, okay? That was our definition. So this is the converse of that. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. Both of the consecutive angles are supplementary. Diagonals bisect each other. And then the last one, this one is new. So both pairs of opposite sides, or I should say one pair, I apologize, one pair of opposite sides is congruent and parallel, then your quadrilateral is a parallelogram. So again, I want all of these properties or ways to prove a parallelogram in your notes. Please take a minute to stop the video if you need to write these down. Okay, our first example. Determine whether the quadrilateral is a parallelogram. So one pair of opposite sides is congruent, the other pair of opposite sides is congruent. So yes, a parallelogram, both pairs of opposite sides are congruent. For B, we have, it's maybe hard for you guys to see, but I have a parallel symbol on there, and both sides are 15. So yes, this is our new one. This is a parallelogram. One pair of I'm going to say opposite sides congruent and parallel. I apologize for whatever that was that popped up. I don't know what's going on. School computer. Okay, find x and y so that the quadrilateral is a parallelogram. So opposite sides are going to be congruent. So 4x minus 1 is equal to 3 times x plus 2. Solving that, subtract the 3x over, add the 1, we get x to be 7. Opposite sides are congruent, so 3 times quantity y plus 1 is equal to 4y minus 2. So I'm going to subtract the 3y over, I'm going to add the 2 over, y is equal to 5. Okay, our coordinate geometry. Quadrilateral RST has those vertices. Determine whether the quadrilateral is a parallelogram. So I always like to draw it out. I guess, yes, you could draw it out, but we need to justify our answer using the slope formula. But we have Q, R, S, T. I don't know where those are located. I just wanted to make sure I'm finding the slopes of the right sides, of the correct sides. So if I find the slope of QR, and that should be congruent to the slope of ST. So my slope of QR is 1 minus 3 over 3 minus a negative 1. That should be equal to the slope of ST. And maybe this is bad notation. I should say here, because it looks like measure of ST. Slope of ST. ST, okay, so I have negative 1 plus a negative 3 over a negative 2 minus 2. So I have a 2 over a negative 4. So one pair is congruent. Now I need to find the other pair. So I need to find the slope of RS. The slope of RS is equal to negative 3 minus 1 over 2 minus 3. And then I need to find the slope of QT. And so that is negative 1 minus 3. Negative 1 minus 3, negative 2 minus, I don't know why, I was literally said 2 and my hand wrote 3. Negative 2 minus a negative 1, so I have negative 4 over a negative 1, which simplifies to 4. So yes, both pairs of opposite sides are congruent gives us, wow, I'm really not doing well today, us a parallelogram. Okay, write a coordinate proof for the following statement. Both pairs of opposite sides, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, so I need to prove that, let's say I'm given the picture. I actually don't even like my given and proof for this. I'm going to prove the opposite sides are congruent. So I need to prove that I'm going to say I'm given the picture. And I need to prove that DC is congruent to AB and DA is congruent to CB. Okay, so I'm going to prove that, let's find the distance of DC. So distance formula, I have B plus A minus B squared plus C minus C squared. So that is the distance of A. AB is the square root of a minus 0 squared plus a 0 minus a 0. So that equals a. We need to find dA now. dA is the square root of b minus 0 squared plus c minus 0 squared. So it's the square root of b squared minus c squared. I'm sorry, b squared plus c squared. CB is b plus a minus a squared plus c minus 0 squared. So that simplifies to b squared plus c squared. So then you want to write kind of a concluding statement. Yes, the quadrilateral is a parallelogram. Both pairs of opposite sides are congruent. Okay, so that is my video on tests for parallelograms, or how to prove a quadrilateral is a parallelogram. Thank you for watching.